Hello, everybody. I'm Chaitra, studying in an SVC college. Today, I'm going to talk about vector calculus. Introduction to vector calculus. Vector calculus is a branch of mathematics that deals with differentiation and integration of vector fields and functions. It extends the concepts of calculus, such as derivatives and integrals, to functions that operate on vectors. Key topics include gradient, divergence, curl, line integrals, surface integrals, and the fundamental theorem of calculus for the line integrals. Vector calculus finds applications in physics, engineering, and various fields involving continuous quantities and their interactions in three-dimensional space. Vectors and scalars. Vectors and scalars are the fundamental concepts in mathematics and physics. Scalars. Scalars are quantities that have only magnitude like temperature, mass, or time. Vectors have both magnitude and direction like velocity, displacement, or force. Vector operations. Vector operations involve manipulating vectors using mathematical operations like addition, subtraction, scalar multiplication, and dot product. Dot product and cross product. Dot product. The dot product, also known as scalar product, of two vectors measures their similarity or alignment. It's calculated by multiplying the corresponding components of the vectors and summing up the results. The dot product results in a scalar value and it can be used to find the angle between two vectors and perform projections. Cross product. The cross product, also known as the vector product of two vector fields, a new vector that's perpendicular to the plane formed by the original vectors. The cross product results in a vector and is commonly used in physics and engineering to find torque, angular momentum, and more. Gradient. The gradient is a fundamental concept in vector calculus that represents the rate of change of a scalar field. It is a vector that points in the direction of a slope increase of the scalar field and has a magnitude that indicates the rate of change. Divergence. Divergence measures the rate at which a vector field spreads out from a given point in space. It helps us to understand the behavior of vector fields in terms of their sources and converge. Curl. Curl means it measures the rotation or circulation of a vector field around a point. It helps us to understand the rotational behavior of vector fields. Applications of vector calculus. Physics, engineering, economics and finance, robotics, and science. Physics, electromagnetism. Vector calculus is essential for describing electric and magnetic fields using Maxwell's equations. It helps us to analyze electromagnetic waves, antennas, and circuit theory. Fluid dynamics. The concepts of divergence and curl are used to study fluid flow, turbulence, and pressure distribution in fluids. Engineering. Mechanical engineering. Vector calculus is used to analyze forces, motion, and stress distribution in mechanical systems. It's crucial for designing structures and mechanisms. Aerospace engineering. It's employed to model aircraft and spacecraft trajectories as well as the behavior of fluids around them. Machine learning. Gradient descent, a technique from vector calculus, it is used to optimize models in machine learning algorithms. Image processing. Vector calculus is applied to edge detection, image filtering, and other image processing techniques. 3D graphics. Vector calculus, it is used to manipulate and render three-dimensional objects in computer graphics, enabling realistic visual effects and animations. Economic and finance. Vector calculus is used in economics and finance to find optimal investment strategies by maximizing returns while minimizing risks. Robotics. Robot motion planning. Vector calculus aids in planning the trajectories and paths of robots to accomplish tasks efficiently and avoid obstacles. In science, environmental science, vector calculus assists in modeling atmospheric and oceanic circulation patterns as well as heat transfer in the Earth systems. Biomechanics. Vector calculus is used to model and analyze forces, motion, and fluid flow in biological systems such as blood flow and muscle movement. So we came at the end conclusion. Vector calculus, it is a powerful mathematical framework that extends the principles of calculus to vector fields and functions. Thank you.